In lesson 5.7, can Rory hit it that bar? We'll be calculating more complicated probabilities. Refer to the previous example. What percent of Rory's drives travel between 305 and 325 yards? Let x be the distance the ball travels on a randomly selected shot with his driver. Suppose that x follows a normal distribution with a mean of 304 yards and a standard deviation of 8. So what I'm going to begin with is I'm going to begin with drawing the normal curve with the mean labeled in the center, the standard deviation 8. What I need to now do is I need to figure out what percent of his drives travel between 305 and 325 yards. So I'm trying to determine that probability or that shaded region under the normal curve. So what I'm going to first do is using table A, I need to find z-scores. So I'm going to calculate the z-score for 305 and for 325. So remember to calculate a z-score. Take your value, subtract the mean, and divide by the standard deviation. And when using table A, we round to 2 decimal places. So to use table A, we're going to look at the probabilities to the left of each z-score, and then we're going to subtract them. So that's going to give us to the left of the z-score of 263 is the 0.9957. To the left of the z-score of 0.13 is the 0.5517. Subtracting them gives us this probability. So about 44% of Rory's drives travel between 305 and 325. You can also use technology to determine this answer. Technology will give you a slightly different value because of the rounding that we did with the z-scores, but it's still very close and both are accurate. If you'd like more practice determining probabilities with the normal curve, please try exercise 5.